and sharing my screen. So today's March 12th. Last class we started looking at equations that were not quadratic. We looked at equations of a higher degree with exponents higher than 2. We said to solve those, we were going to factor completely and set each factor equal to 0 and solve. And we started looking at radical equations, and I think we only got to the point of looking at radical equations with one radical in them, but everybody seemed okay with those. Today we're going to look at equations with 2 radicals, equations with rational exponents, and equations that are quadratic in nature. They're not quite quadratic equations, but they behave like them. If there's time, we'll also start looking at inequalities, but I'm not so sure about that. Homework 1.5 is due to on Monday. That's that homework on quadratics. And oh my heavens, I just remembered that I had promised that if people got that homework done by today, I was going to give you extra credit. And so after class, I'll go through and see how many people got through that one, and I'll give those folks extra credit. Homework 1.6 is on those equations that we're working with. That'll be due next week. Homework 1.7 is on those inequalities and problem set 2. Those are all due next Friday. Kind of next Friday is the end of the chapter. So again, I would strongly recommend that with most of those, you don't wait until the night before to do them. So because the end of the chapter is next Friday, hopefully we'll be going over their problem set next Friday in class, and exam 2 will be available over the weekend. This weekend, there is a quiz. The quiz involves solving quadratics. There's one of each type, one where you have to solve by factoring, one where you have to solve using the square root property, one that you have to solve by completing the square, and one that you have to solve using the quadratic formula. And there's also some questions involving complex numbers where you have to multiply complex numbers, multiply a complex number by its conjugate, rationalize the denominator, or divide complex numbers. And then there's also a question where you have negative square roots and you have to simplify that and write it in A plus BI form. Does anybody have questions on any of those things that are going to be on the quiz this weekend? Or does anybody want to look at any of the problems from homework 1.5 or 1.6, or even any of the homeworks before that?
I'm all good.
You're all good? Anybody else want to go over any of that?
Hi, Miss. This is off topic, but I just got in like 2 minutes ago.
Rezwana?
Yeah.
Yeah, you know what? I let you in and I didn't adjust the attendance. I was going to get you at the end of the class, but I'll get you now. And Mark, you just got in too. Was there anybody else who came in after I took attendance? If not, and if there are no questions, which surprises me, because the Tuesday, Thursday class had lots of questions yesterday. But if there are no questions, let's go look at radical. Go ahead.
Mark's here now, but I didn't hear what you said, so I might have a question.
Okay. What we'd said was that homework 1.5, which deals with quadratics, is due on Monday, but I had said that I would give you guys extra credit if you got it done by today. After class, I'm going to go through and see if anybody's got that extra credit. Homework 1.6, which is on those equations. Homework 1.7, which is on inequalities. And problem set 2 will all be due next Friday, so don't leave any of them go until the night before. Exam 2 will be open next weekend. This weekend, there is a quiz. In my labs, you submit a picture of your work in Blackboard on solving quadratics and simplifying complex numbers, multiplying, dividing, putting negative radicands in terms of I, quadratic formula. There's one you have to solve by factoring, one using the square root property, one using completing the square, and one using the quadratic formula. And again, in your work, I want to see that you use the method asked for.
Okay, thanks.
All right. Then we left off looking at radical equations, and we had said in general we were going to isolate a radical and square both sides. We did a couple of those. Today we're going to start by looking at radical equations with two radicals. And if it has two radicals, it's going to be like that old gum commercial, double the fun, twice the fun. I'm going to have to square it twice. Let's look at an example and go through how to do it as we work through that example. And here that I was talking at the beginning about me being jinxed technology-wise today. The stylus wasn't working. So let's look at an example. Let's look at something like the square root of x plus 5 minus the square root of x minus 3 is equal to 2. And notice this is different than the other ones because it's got two radicals. And so I can't just square it once. If I did, multiplying what's on the left by itself would get quite ugly. So what we want to do first is we want to isolate one of the radicals. We want to get one of those square roots alone. I don't know about you guys. I think most people like positive quantities better than negative quantities. So I'm going to start by getting this first radical alone. And to get that first radical alone, I'm going to add the square root of x minus 3 to both sides. On the left, I'll just have that square root of x plus 5. On the right, I'm going to have 2 plus the square root of x minus 3. They're not like I can't combine them. Now, I'm going to clear one of the radicals by squaring both sides. But here we've got to be super duper careful. If I square what's on the left, that gives me x plus 5 quantity squared is equal. On the right, I'll have 2 plus the square root of x minus 3 squared. We'll do the easy side first. We said a couple of times that raising something to the second power and taking the square root are opposites, inverses. They undo each other. And so if I square a square root and multiply it by itself, I'm undoing that square root. And it has a net effect of actually just taking the square root symbol away and giving me the radicand. I get x plus 5. But over here on the right, when I square that, there's addition in the middle. That looks like a binomial. I have to think of taking that quantity and multiplying it by itself. Or I have to think of using that formula that we talked about completing the square in terms of squaring the binomial. Again, a lot of people don't remember that formula, so I'm going to take the time to over here multiply it by itself. Doing that multiplication, you can think of distributing twice, or you can think of foiling, or some people like to draw the box. But as I FOIL, first, 2 times 2 is 4. That wasn't too bad. Outer, 2 times the radical. Well, I'd have to literally get 2 times the radical. I'm sorry, that's radical 3. Inner, I would again get plus 2 times the radical. Last, when I take that square root and multiply it by itself, That's squaring the square root. And so I just get that radicand. And so do you see how messy it is when you multiply that binomial with a constant by itself? If I were to, at the beginning, try to square it without getting that radical alone, multiplying that binomial by itself with two radicals would have gotten much more involved algebraically. So now on the left, I've got my x plus 5. On the right, I've got some like terms. 4 minus 3 is 1. I only have that single x term. And then when I take 2 times the radical plus 2 times the radical, I get 4 times that x minus 3. And now this equation looks much more like those equations we looked at last class with only one radical. So now we're going to do what we did with those, which is isolate the remaining radical. Or we're going to try to get this square root of x minus 3 alone. So I think I'm going to subtract 1 from both sides. And also subtract x from both sides. And so on the left, I'm just left with 4 equals. On the right, I'm just left with 4 times the square root of x minus 3. Now, again, I want that radical all alone. So I'm going to divide by its coefficient 4. And what I do to one side, I have to do to the other. So that leaves me with 1 equals the square root of x minus 3. And I've got that radical all alone. And now, does everybody remember last class, once we got that radical all alone, we're going to again square both sides. And so that gives me 1 squared is equal to the square root of x minus 3 squared. 1 squared is 1. And as we said previously, when I square a radical, I just get the radicand. It's kind of like taking that hat off. And now I've got an equation that I can solve. So here, to solve this, all I need to do is add 3 to both sides. And I get x equals 4. And if you remember last class, we said when we square both sides, we can sometimes get extraneous roots. If we square both sides twice, it's probably twice as likely to get them. So we always want to check in the original. And I know I scrolled way down. The original equation was the square root of x plus 5 minus the square root of x minus 3 equals 2. And if I substitute my answer, x equals 4, that gives me the square root of 4 plus 5 minus the square root of 4 minus 3. 4 plus 5 is 9, so that's the square root of 9, minus 4 minus 3 is 1, that's the square root of 1. The square root of 9 is 3, the square root of 1 is 1, 3 minus 1 is 2 equals 2, and it checks. I think there are only 2 of these in your homework, 2 of them with 2 radicals. You're not going to see it a lot, but what you have to remember is that if I have 2 radicals, I've got to go through and I have to go square it twice. Questions? Should we try another or, oh yeah, let's try another. Everybody got this one down?
Yep.
So then our next example, let's say I have the square root of x minus 5 minus the square root of x minus 8 equals 3. Again, we've got two radicals on the same side. So the first thing that I want to do is I want to isolate that first radical. So I'll add the square root of x minus 8 to both sides. Giving me the square root of x minus 5 equals 3 plus the square root of x minus 8. Am I correct in assuming that everybody's okay with that part? If so, the next thing that we want to do is we want to square both sides. And remember, squaring that right-hand side, you have to think of taking that expression and multiplying it by itself. And I'm going to stop here for a minute and let you folks do that to make sure you're comfortable with foiling something like that out. I'm going to be quiet for a minute and ask you folks to do that part for me, please. How are you folks doing? Did everybody else get on the left x minus 5, on the right 1 plus x plus 6 times the square root of x minus 8? Any questions? You guys hear me?
Yep.
We good so far?
Yeah.
So then we want to get that other radical alone. So we'll subtract 1 from both sides, and we'll subtract x from both sides. And I get -6 equals 6 times the square root of x minus 8. And to get that radical all alone, we're going to go through and we're going to try to divide both sides by 6. Giving me -1 equals the square root of x minus 8. Oh dear, now what should I do? Does everybody remember to undo that radical? The opposite of taking the square root is squaring. So I'm going to take both sides of that equation and square them. Giving me 1 equals x minus 8. And that's not too bad to solve. I'll add 8 to both sides and get x equals 9. Again, though, these are one of those types of equations that I don't want to leave with out check. And so checking my original equation, yikes, I didn't have it written down. Square root of x minus 5 minus the square root of x minus 8 equals 3. Gives me, substituting a 9, the square root of 9 minus 5 minus the square root of 9 minus 8. Well, that would be the square root of 4 minus the square root of 1, which gives me 2 minus 1, or 1. Oh, does 1 equal 3? Anybody? Does 1 equal 3?
No.
I don't think so. And so we're going to reject the solution and say that there is no solution. Or the solution set is the empty set. We can have the braces with nothing, or we can have the symbol for the empty set, the 0 with a slash through it. And so again, there's a lot of work that goes into these, squaring it twice. None of it too hard, but there is a lot of work. And it's always important that we do that check at the end, because sometimes we get extraneous roots. Everybody okay with solving these equations with two radicals? Square it twice.
Okay.
If there are no questions, then the next place that we're going are equations with rational exponents. And whenever I see that word rational, I look inside at the word ratio. Remember, a rational exponent is when we have an exponent that's a fraction. So a few things that we have to remember before we do these. First is, if I have a variable or any quantity to a fractional exponent, x to the n over n, does everybody remember, if the exponent is a fraction, I've got a radical. The base is the radicand. The denominator is the index on the radical, and the numerator is the exponent. I can write it like that, or I can write it like, that should be n, by the way, I apologize. Yeah, they're both interchangeable. So for example, if I have 8 to the 2/3, does everybody remember? I'm taking a root. My base is 8. The index is the denominator, 3, so I'm taking the cube root of 8 and then squaring it. The cube root of 8 is 2, and when I square that, I get 4. Does everybody remember that?
Sure.
Next thing you have to remember is, if I have a power to a power, does everybody remember we multiply those exponents? And the third thing that you need to remember is, if I multiply a fraction by its reciprocal, the product is 1. And so I need to have all of those things in mind when I solve an equation with rational exponents. So let's look at an example and see if we can summarize what we need to do to solve it. Let's say I have x to the 3/2 plus 3 equals 30. The first thing that I want to do is isolate the expression with the rational exponent. And so that in this equation would be the x to the 3/2. So I want to get that part alone. Is everybody all right to do that? We subtract 3 from both sides. And I get x to the 3/2 equals 27. Sorry about that, guys.
Great song.
Yeah, I just figured that would be a good ringtone, right? Next thing, it's loud enough to make me jump. We're going to do is we're going to raise both sides to the reciprocal power. So where I have x to the 3/2 equals 27, the reciprocal of 3/2 would be 2/3. And so I want to go through and raise both sides to that 2/3 power. Then I'll simplify. Well, over on the left, we said when we raise a power to a power, we multiply those exponents. And we chose the reciprocal because when I take 3/2 times 2/3, I get an exponent of 1. X to the first are just x. On the right, if I were to simplify that by hand, because that exponent is a fraction, I know I need a radical. My radicand is the base, 27. My index is the denominator, 3. And I'm going to raise it to the second power. Hopefully, everybody recognizes the cube root of 27 is 3. And when I square it, I get 9. And then we'll check. Again, in terms of those rational exponents, it's important that you can go through and take this expression and rewrite it with a radical. In terms of evaluating it, I know some folks don't have that level of confidence with the numeric skills. And so did we talk about earlier in the semester how you could evaluate that 27 to the 2/3 with a calculator? Does everybody remember how to, if you can't do it by hand? Do you need me to walk you through the steps, or can everybody get that 27 to the 2/3 is 9 on their own?
I'm good.
Everybody's good? Okay, great. So now let's do our check. Our check, x to the 3/2 plus 3 has to equal 30. Well, 9 to the 3/2 plus 3 would be the square root of 9 cubed plus 3 would be 3 to the 3rd plus 3, or 27 plus 3 equals 30. and it checks. So far, so good. If so, let's try another example. This time, let's look at something like x plus 5 to the 2/3 minus 4 equals 0. And so here, we want to get that expression with a rational exponent alone first. So I'll add 4 to both sides, giving me x plus 5 to the 2/3 equals 4. Now I want to go through and raise both sides to the reciprocal power. So I'm going to take that x plus 5 to the 2/3 and raise it to the 3/2. And I want to take 4 and raise it to the 3/2. On the left, when I raise a power to a power, I multiply those exponents, and that product will be 1. So that gives me x plus 5 to the first, or just x plus 5, equals, on the other side, 4 to the 3/2 would be the square root of 4 cubed. With this one, we want to be careful, because when I look at the square root of 4, does everybody remember every number has 2 square roots, a positive and a negative? So the square root of 4 could be 2, or the square root of 4 could be negative 2. So that gives me x plus 5 equals 2 to the 3rd, or x plus 5 equals negative 2 to the 3rd. So I get x plus 5 equals 8. And subtracting, I get x equals 3. Or I get x plus 5 equals negative 8. And subtracting, I get x equals negative 13. So this time we've got 2 things to check. Again, our original equation was x plus 5 to the 2/3 minus 4 has to equal 0. When x equals 3, that gives me 3 plus 5 to the 2/3 minus 4. We want to know, does that equal 0? Well, that would be 8 to the 2/3, or the cube root of 8 squared, which would be 2 squared, or 4 minus 4 equals 0, and it checks. Now if I check when x equals negative 13, I get negative 13 plus 5 to the 2/3 minus 4. I want to know, does that equal 0? Well, that's negative 8 to the 2/3 minus 4, or the cube root of negative 8, which is negative 2 squared, which would be 4 minus 4 equals 0. And here they both check. So if I have an expression with a rational exponent, what I need to do is an equation with a rational exponent, pardon me. What I need to do is get that part with that fractional exponent alone on one side of the equal sign. Raise both sides to the reciprocal power. Simplify. And then check in the original. So I'm going to give you guys one more to try on your own. This time, let's look at 8 times x to the 5/3 minus 24 equals 0. And so I'm going to be quiet for a minute and ask you folks to look at that and tell me what you get. Did everybody get the 5th root of 27? Or at least, did everybody get to this part here that x equals 3 to the 3/5? Does anybody have a question as to how I got to that point?
Never a question.
No questions? You're okay, Jacob?
Yeah.
Okay, then to simplify that, 3 to the 3/5. Again, usually when I do them computationally, I say that the denominator is the index and the numerator is the exponent, but I can't take the 5th root of 3, it's an irrational number. And so sometimes it's easier if you use the exponent first and then take the root. And so because 27 doesn't have a 5th root, that's an irrational solution, and we're going to just leave it right there. So if we've got an equation with a rational exponent, our goal is to get the part with the exponent alone, raise both sides to the reciprocal power, and simplify. If there are no questions, the next thing that we have, the last thing in this section, section 1.6, is equations that are quadratic in nature. And so you might be wondering, what does that mean to be quadratic in nature? Well, if you can remember, we said that the general quadratic was ax squared plus bx plus c equals 0. Looking at that, we notice that it's I'm sorry, my stylus just decided it didn't like me. It's a trinomial. It's in descending order. One side 0. And as we look at it, there's a constant term. And as I look at the first and second term, you notice that one exponent is twice the other. And so that's the pattern that we're going to be looking for to say that we have something that's quadratic in nature. So how are we going to deal with these? We're going to do something that is called use U substitution. I'm sorry, this stylus just does not want to work. And so what does that mean? Let's look at an example. Let's say I have 4x to the 4th is equal to 13x squared minus 9. The first thing that I want to do is see if indeed it is quadratic in nature. So I'm going to make one side 0. And put the other side in descending order. So, does everybody see that here? That would be subtracting the 13x squared from both sides and adding the 9 to both sides, giving me 4x to the 4th minus 13x squared plus 9 equals 0. And now, does it fit that pattern? One side 0, I'm in descending order, I have a constant term, and over here, do you see how one exponent is double the other? So what we're going to do is we're going to substitute a dummy variable. Usually people use U. For the variable part of the middle term. What the heck does that mean? Does everybody have the words down? Are you guys all right if I pick up from here, or do you need me to be quiet for a minute? Are we good? Not hearing any complaints. The variable part of this middle term is x squared. So what I'm going to do is I'm going to let u equal x squared. Well, if u is x squared, wouldn't u squared be x to the fourth? And so I then get my equation substituting x to the fourth is u squared, x squared is u. My constant stays the same. And now I do have a quadratic equation that I'm going to solve. So let's solve the resulting quadratic. And I do believe this one's factorable. Our signs are the same, both minus. And I kind of noticed that 13 is the sum of 9 and 4. So I think that if I use the 4 and the 9, that'll give me that 13 in the middle. So I get 4u minus 9 equals 0, or u minus 1 equals 0. On the left, I'll add 9 to both sides. 4u is 9. And then dividing, I get u is 9/4. On the right-hand side, I'll add 1. And I get u is 1. Yay, we've got solutions. But wait a minute. We know what u is equal to. But we want to know what x is equal to. So now we have to back substitute. For u to solve for the original variable. What? Back substitute for u? What does that mean? Well, up here, we had said that u is, well, I wanted to do that with the highlighter, u is x squared. So I'm going to go down here and say, well, u is x squared. So that tells me x squared is 9/4, or x squared is 1. And so if I use my square root property, I get x could equal the positive or negative square root of 9/4, which gives me 3/2, or negative 3/2. And here I'd get x is equal to plus or minus the square root of 1, which would give me 1 or negative 1. And then we should check each in the original. And so technically for this one, we should do 4 checks. I hope everybody knows how to do a check. And so are you guys all right if, in the interest of time, we don't take class time to do these checks? We okay? Not hearing any complaints. Let's look at another example, which is kind of fun because it combines what we know about quadratics with what we know about rational exponents. Let's say I have 2x to the 2/3 plus 7x to the 1/3 minus 15 equals 0. With this one, does everybody notice I have a trinomial? I've got a constant term. And as I look at the variable parts, isn't 2/3 double of 1/3? So this fits that pattern, quadratic in nature. So I'm going to let u equal the variable part of that middle term, x to the 1/3. And so when I look at u squared, that's x to the 1/3 squared. And when I multiply exponents, that gives me x to the 2/3. So when I substitute, 2x to the 2/3 would be 2u squared plus 7x to the 1/3 would be 7u minus 15 equals 0. That one I believe is factorable. If I look at 2u squared, it'll be 2u times u. 15, I think if I use 5 times 3, different signs. If I go plus 5 and minus 3, when I FOIL, that would give me 10u minus 3u, which gives me 7. Now that it's factored and one side is 0, we'll set each factor equal to 0. And solve those equations. The first one, I'll add 3 to both sides, and I'll get 2u equals 3, and then dividing by 2, I'll get u is 3/2. And then on the other side, subtracting 5 from both sides, I'll get u equals -5. Now, when I go to back substitute, u is x to the 1/3. So x to the 1/3 equals 3/2. Over here, the other possibility would be x to the 1/3 equals -5. Well, we just said if we have a fractional exponent, we'll raise both sides to the reciprocal power. And that gives me x equals 3 to the 3rd is 27 over 2 to the 3rd is 8. On the other side, when I have x to the 1/3 equals -5, when I raise both sides to the reciprocal power, I'll raise them to the 3rd. And that gives me x equals -125. And so if I've got something that's a trinomial, where the descending order, where the exponent, pardon me, on the first term is double the exponent on the middle term, I'm going to treat it like quadratic. Then, after I do that u substitution and solve for u, I'll go back and look at that definition of u and solve now for x. Thoughts? We okay, folks?
Yeah.
Yep. All right, then one last type of equation that we're going to find in this section, and that's absolute value equations. And before we look at solving absolute value equations, let's remember that definition of absolute value. And let's look at the absolute value of two numbers. If I take the absolute value of 5, well, absolute value is always positive. 5 is already positive, so that'll be 5. And does everybody remember if I were to take the absolute value of -5, well, wouldn't that have to be the opposite or 5? And so do you notice if the absolute value is 5, then the original quantity inside those absolute value bars could be positive or -5. We could summarize that by saying that if the absolute value of some x was equal to 5, by what we just saw, that x could be 5 or x could be -5. And we can generalize that then and say, in general, if the absolute value of x is equal to some quantity a, then x can equal a, or x can equal its opposite, the negative of a. And so I like to remember that if I have an equation with an absolute value, that absolute value has 2 bars. And the 2 bars remind me that I'm going to turn that into 2 equations. So to solve an absolute value equation, and again, let's go through an example as we work out how to do this. I've got, let's say, the absolute value of x plus 1 minus 3 is 2. I apologize. These are my absolute value bars, and this is the number 1. The first thing that I want to do is get the absolute value alone. So let's isolate the absolute value. So to get that absolute value alone, I'm going to add 3 to both sides. Gives me the absolute value of x plus 1 is equal to 5. Now what I want to do is I want to write 2 equations. Remember, if the absolute value of x is equal to some quantity, then what's in there could equal that quantity, or what's in there could equal its opposite. So on the right-hand side, I'm going to just lift the bars. I'm never going to worry about the signs within the bars. I'm just going to lift the bars. That's going to give me x plus 1 equals, it can be that number, or x plus 1 can equal that opposite of that. We'll solve those resulting equations. So in the first one, I'll subtract 1 from both sides. and get x equals 4. Second one, I'll subtract 1 from both sides and get x equals -6. And this one, it's important that you check all your solutions in the original. So my equation was the absolute value of x plus 1 minus 3 equals 2. If x equals 4, I get the absolute value of 4 plus 1 minus 3. Does that equal 2? Well, 4 plus 1 is 5. The absolute value of 5 is 5. And 5 minus 3 is 2, so it checks. And if x equals -6, the absolute value of -6 plus 1 minus 3, does that equal 2? So that's the absolute value of -5 minus 3. The absolute value of -5 is 5 minus 3 equals 2. And it also checks. I think we probably just have enough time to do a couple more of these. So let's look at next example, the absolute value of 2x minus 3 minus 8 equals 3. First, we want to get those absolute value bars alone on one side. So I'm going to add 8 to both sides. Gives me the absolute value of 2x minus 3 is equal to 11. Now again, 2 absolute value bars reminds me I want to break this into 2 equations. For the first one, it doesn't matter the signs inside. I'm going to just take what's inside the absolute value and set it equal to the other side. Or again, what's inside the absolute value stays the same. I change the sign on the other side. Now solving the resulting equations. First, if I add 3 to both sides, add 2x equals 14, and dividing, I get x equals 7. On the other side, if I add 3 to both sides, I get 2x equals -8, and dividing by 2, I get x equals -4. So now when I check, the equation is the absolute value of 2x minus 3 has, minus 8 has to equal 3. So if I take the absolute value of 2 times 7 minus 3, then subtract 8 from that, do I get 3? Well, that's the absolute value of 14 minus 3 is 11, minus 8. The absolute value of 11 is 11, minus 8 equals 3, and it checks. On the other side, when I replace x with -4, does that also equal 3? Well, that's the absolute value of -8 minus 3 is -11 minus 8. Remember, the absolute value of -11 is 11. 11 minus 8 is 3. And it also checks. How's that look?
Splendid.
Okay, just be real careful. When we write that second equation, remember the sign changes on the other side, the side that does not contain the absolute value. I'm going to give you folks one to try on your own. I'm going to ask you to solve the absolute value of x plus 1 plus 3 equals 2. And I'm going to be quiet and ask you folks to look at those. While we're doing that, I want to double check attendance. Jenna, Stephanie, Azim, you came in, right? Jatara, Tom? Did we get Tom? Yeah. Nicholas? So I'm adding Azim and Tom.
You got Mark too, right?
Mark, did I get you? I got you first time around.
Okay, thank you.
Did anybody else get that this equation has no solution?
Yep.
Yeah. All right. Did anybody notice? I mean, I went through and worked the whole thing out to see that it has no solution. But I'm thinking I probably could have stopped a little bit before then, because if I look over here, do you see how I'm saying that the absolute value is equal to a negative number? By definition, will absolute value ever equal a negative? No, absolute value is always positive. So at that stage of the game, I probably could have stopped and said, no, this isn't going to work. But there's no harm in working it all the way through and showing with the check that it doesn't work. So We did a lot today. We looked at equations with two radicals. We looked at equations with fractions and the exponents. We looked at equations that combined some of those topics to look at quadratic in nature, where we have a trinomial descending order, constant term, a term with an exponent, and the higher degree term having double the exponents, and said, well, we can use that U substitution to turn it into a quadratic to make it easier to solve. But then we have to go back and remember we want to solve for the original variable, not U. And we also looked at absolute value equations. That absolute value symbol has two parts to remind me that in order to solve that absolute value equation, I've got to solve two equations. Any questions? Not hearing any, I'm going to stop sharing. Stop